Hi everyone. Today's video I'm going to talk about our power system in our mini camper van. We've gotten a lot of requests from people to go into a little bit of detail on what I've done for our vehicle. And so I first want to start by saying there's a lot of different ways that you can go about this. I'm not advocating that this is the correct or best way. It's just the way that I did it. I wanted to build it into a single board that was easy to remove from the vehicle to work on. I found it actually easier to be able to build the system in the shop and place it in the vehicle when it's ready. That way, when I need to take it out, it's easy to take out, make changes. Just found it made life a lot easier for us. Okay, let's start our tour on the passenger side of the power board. There are connectors out here for bringing in solar power. This is a 20 amp connector, an XT60 style connector coming in from the 100 watt solar panel. The solar panel max current is going to be in the range of maybe 5 or 6 amps, so this is plenty of capacity for that application. This is output leads for 12 volts to some DC loads like lighting and fans on this side of the vehicle. Also power ports and USB ports. This is just a temperature sensor input for the solar charge controller. It's got a connector into the controller here, and I just set the probe over near the battery so the temperature conditions can be read by the controller. What's not shown here is I have a communication line from the controller out to a remote readout panel that you probably saw in some of my other videos, and it gives me a way of looking at what's going on with the system without having to get underneath and look at this readout here. This solar charge controller is an MPPT 20 amp unit. It's a lot larger than I need for a single 100 watt solar panel. I sized it for future needs as well. If I add another 100 watt panel, maybe a flexible panel that I can set up to aim at the sun, this will be able to handle that. So I didn't want to go and have to get a different controller. So that's it for coming into this side, and I'll just walk my way through the board. The solar input first comes into a shutoff switch. So I feel it's really important to have a shutoff that's easy to get to for the solar panel coming in, and also for battery coming into the board. Plus these charge controllers like to have a sequence followed when you're shutting off power. You never want to have the solar panel coming in to the charge controller without the controller being hooked to the battery. So I have labels here to remind me to shut off solar first and then the cabin battery in that sequence, or to turn it on in the opposite sequence. Turn on the cabin battery and then connect the solar panel to the controller. So solar comes in through the switch. It then comes in through a fuse for input then into the controller. There's 3 main circuits in the controller. There's solar in, there's battery power out to charge the battery, and then there's a load circuit here that I'm using to power up all my DC loads. All 3 of these circuits I take through their own fuses here for safety's sake. Looking at the load's coming out through its fuse, comes into this main fuse block here where all my DC circuit loads are powered. I've got 2 separate circuits coming off here that go off to passenger side, 2 DC circuits coming off this side to go off to the driver's side, and a refrigerator circuit here. These are these are a 14 gauge wire on the smaller circuits and 10 gauge wire for the fridge, and 10 gauge really for all of the leads going into the controller. Over here is negative bus bar, so all the negative leads from the different circuits come in through here and are connected together. And over here is a switch I haven't talked about in the past, but it's a switch that allows me to bypass this entire power board in terms of power supply and connect to a remote power supply. In my case, it's a jump battery. So I can power, let's say I had a problem with something here and I didn't have time to diagnose it, or it was serious enough I just had to shut this off. I can still power the DC loads from a remote battery just by switching this over, and it bypasses this battery and this system and just comes in from like a jump battery connected to the outside. So let's see, coming down to here, this is the main connector to the battery. It's got another connector that mates here, goes into a shutoff switch, and then goes to the battery. And we have hot lead comes into a main cabin battery fuse. I have a 250 amp fuse here, and then it goes off to the inverter. Negative just comes through a common connector here and a junction block here. I used to have a shunt here for power monitoring, but I've removed that and just replaced, put in this this short lead to connect up with this existing lead for the time being. I also have off of here, these two leads are actually the battery leads coming out of the charge controller. So this is how the charging gets to the main battery, by coming in through these junction blocks here and then to the battery. I'm using 2-gauge welding cable for the high current leads. Welding cable is really nice for these applications. It's multi-strand copper, very flexible. It's available in different gauges and lengths, and the cost is not that high. I'm feeding a 1500 watt pure sine wave inverter. So at full load, this might be drawing 125 amps or so of current directly from the battery. And 2-gauge is, for such a short length, is fine to handle that load. Down here I've got the positive coming into a 150 amp fuse. It's a little bit redundant because the inverter has its own internal protection, but can't hurt to have that in case I do something stupid. And then coming back around here, I made up a right angle copper bus bar to tighten up the routing here. Otherwise I'd have to bring in this cable from, coming in like this or from above, and this allowed me to keep the routing real compact. I'm also using that down below on the negative. So negative comes in tight and then right angle into the terminal. On this side of the board, the leads are, first of all, there's a chassis ground that connects to the chassis ground of the vehicle. This green lead is coming off of a post here for the inverter, and there's a green lead coming off a post here for the solar charge controller. So that's for safety. These are two 12-volt circuits coming off of my fuse block here, and this also goes to lighting and power ports on this side. Here, this lead here is that jump battery connector. So when I have this switched over to bring 12 volts in from the jump pack, that's coming in on here. This just has a regular cigarette lighter type of plug that goes into the jump battery. The last connector over here is a 12 volt cigarette lighter kind of port. This is for the refrigerator. There's another XT60 connector here for the refrigerator circuit. This is just an adapter to go from XT60 to cigarette lighter type of thing, which is a standard 12 volt type of power cord for the refrigerator. There's a communication line going off to a remote control to allow me to turn on and off the inverter over near where I've got electrical outlets. Here's a closer look to the other side of the inverter. Give you an idea of the right angle copper connectors. So right here and identical one down here have a solid connection and gives me that other routing option. The other thing I want to show you back here is the inverter is spaced off the ground or the board about 1/2 inch. Make sure that there's space for cooling air to circulate. And I've done that also over here on the charge controller. So there's cooling fins underneath. I want to make sure that air can get to them. I've always got this onboard battery charger connected. It's connected to the battery and connected to a shore power junction box inside the van. That way, whenever we are connected to power, shore power, this will come on automatically. It's set to this type of battery, and we'll top this off if necessary. This puts out a 26 amp max charging rate. This is a 105 amp hour 12 volt AGM deep cycle battery. I contacted the company for their recommendation on battery chargers, and they were happy to have this one connected to this battery. Well, I hope that was useful. As usual, leave comments and questions for me. Happy to get back to you, and we'll see you next time.